Welcome to WasmAssembly episode 14. We're back after a long break due to Google I.O., which has kept both me and our producing team very busy. But we're back, and after David Kirkus from the external company Quadratic, this time I have two Google internal guests again. I have Ömer Ağacan from London, UK, and Martin Kustermann from Aarhus, Denmark. Both work on the Dart team at Google. Welcome to WasmAssembly, Ömer and Martin. Thank you.
Thank you very much for hosting us, Tom.
So before we start talking about WebAssembly, let's give the people who may not be aware of the main programming language that you folks are working on, Dart, some background. So what even is Dart? Can you go into some detail and just briefly summarize for people who may not be aware what Dart is, what Dart is?
Yeah, so Dart is a general purpose programming language. It has been founded over a decade ago. And the origins, they trace back to the development of Chrome. So back then, Google decided that it wants to do a new browser, and it needed someone to make the JavaScript engine in the browser, which turned into V8. And the founders of V8 did a great job optimizing JavaScript, but they were very unhappy with the language itself, with the language semantics, type conversions that happen automatically, performance cliffs that happen if you fall off the happy path. And so they thought it might be a good idea to have a new language for the web. So they created Dart. And it was actually specified by a ECMAScript committee. So even today there's a ECMA 408 specification of Dart, but it is almost 10 years outdated because moving a bit forward, it turned out that the Dart VM did not end up in Chrome. There were some interesting reasons. For example, when you put to-do programming language implementations in a browser, and you have two VMs, two cheating VMs, two garbage collectors, then objects from one might reference DOM nodes, which might reference objects from another. And you have a problem of collecting garbage across those two different heaps and a ref counting DOM node system in between. Actually, someone from the Dart team then had a tangent. He worked on Chrome on the rendering engine to turn the C++ rendering engine, the Blink, into a garbage collected system as well. From previously it was ref counted. The project was Oilpan, and so that ended up being used in production. But that still didn't end up in Chrome, and so there was not this huge success that the founders of V8 and Dart have hoped for. We got some adoption internally, especially by the ads team, and also some externally, but not as big. And then there was a parallel track where the founders of Flutter started experimenting with kind of a stripped down version of Chrome, and then they got to know Dart, and then we had a very good customer, collaborator also, and we kind of developed alongside.
Oh, wow. So there's a long history there. But before we dive into Flutter and why they chose Dart, let's maybe take one further step back and go back to before the Blink fork happened. So in the beginning, there was WebKit, and WebKit had as a JavaScript engine JSC. And then the Blink fork happened. You essentially started from the fork. But there was a decision to actually write a new JavaScript engine, which was eventually becoming V8, right? So that's what you mentioned here. But there was this point in history where it could have been that we would have had, whoa, that's quite a lot of hard English grammar here. So if we would have had two programming languages supported by this V8 engine, and one of them could have been Dart, the other could have been JavaScript, as we have today. That's quite exciting there. So I remember attending some meetups called, I think it was back at the day, a series of meetups called Dart Flight School. And we were shown how to use Dart, how to handle it, how to program with it. But but yeah, eventually this ended up not becoming a thing. Maybe very briefly on oil pan. So can you just give us some more background there? Like what oil pan, what is the name? Why is it called oil pan? What is behind that?
Yeah, that's a good question. I forgot why they named it oil pan. Um, but yeah, so one of the motivating factors is that we maintained, so the Dart team maintained a fork of Chrome. We called that fork Dartium, and it had the V8 and the Dart VM inside. But the way it was implemented is it was not ingesting Dart source code and running it on V8, but it was running on a separate virtual machine, the Dart VM, with its own JIT compiler, with its own garbage collector. And so when you have these two kind of independent systems in the browser, uh, you create this problem that I kind of alluded to earlier, that via DOM nodes, via some shared nodes, you can create references. So you can attach like DOM nodes hang on to event listeners and many other kind of things inside Dart or JavaScript. And you can create references from one heap, from, for example, JavaScript to a DOM node, which then references a Dart object, and they can create cycles. And this also independent of having Dart and JavaScript and V8 in Chrome, it also had problems that the middle part, the DOM, it was ref counted, and you can still have cycles sometimes. So they had to be very careful, for example, to use weak references that you don't create memory leaks. And break kind of ensure that when you free a part, there's no use after free. And there was a lot of security vulnerabilities as well due to this ref counting business and these weak references and this manual memory management. And so OilPen tackled that problem. And in addition, it would have been maybe a benefit to having a Dart VM in Chrome as well, which in the end didn't happen.
There was a fallback where you could compile Dart to JavaScript, just like today you can compile TypeScript to JavaScript. But yeah, so mentioned essentially this entire Dartium Dart per se was not a huge success, but then Flutter came along. So what is Flutter? What do people use Flutter for? Can you just provide some background on the Flutter framework as well?
Yeah, so Flutter is one of the most, maybe the most popular cross-platform framework for developing UI apps. It runs on mobile, on web, also I think on some TVs maybe. And the goal is to run on anything with a screen on it. And it had kind of interesting roots also. So just like Dart was founded by the former engineers of the JavaScript engine in Chrome, V8, Flutter was founded by the former leaders of the Blink, the rendering engine in Chrome, the graphics part of it. So they were not very happy with some of the web technology stacks, floating CSS layouts that caused kind of non-local effects. You change your app a little bit and performance will be very different in terms of like how much computation for the layer has to be done in this rendering stack. And so they took Chrome and then they strip away more and more parts. And there was like a temporary project called Sky, which later on turned into Flutter. And they initially actually used JavaScript as a language, just like Chrome used to use, and they had a DOM, some markup language and a scripting language. But eventually, over several iterations, they decided that they want to hoist more out of the C++ part. They don't want the DOM nodes to be in C++ anymore. They also found out that I think they tried to make it with that system, with web technology, an identical version of the calculator app for Android or something, and they failed because something could not be expressed very well with the DOM APIs. I'm not an expert, but there's a great episode where the founders of Flutter talk about that. Maybe we can link in the show notes to that.
Maybe we'll link to it in the show notes. Yeah. So, as I say, Flutter is a quite revolutionary approach to doing web programming. So it's not just web, but also web. So you can compile to native, anything that has a screen, as you said. But like focusing on web a little bit here. So the approach is revolutionary in a sense that they throw away everything that we tend to have in web. So everything is rendered pixels on a canvas. There's nothing much. If you look at the DOM tree, it's essentially a canvas and nothing more. But then people started picking on them a lot because of accessibility and things being lost. The good news is Flutter had a bunch of I/O moments, like Google I/O moments, where they announced a lot of changes. So, for example, they now announced that they have improved accessibility support a lot. We will link to those moments in the show notes as well. And I've also dug a bit into the accessibility approach in Flutter, how to make Flutter apps more accessible, and a Medium blog post on their blog. So there's some changes here. But yeah, the approach definitely is revolutionary if you think of a classic web programmer approach of building applications with DOM elements. There was a second DOM, not DOM, a second JavaScript hot reload moment at Google I/O where they said, now what people have been used to doing in Flutter Native, where you can just make changes to the code and then have hot reloaded in your Android application, in your iOS application that you may be building and see the changes. They also started to ordering this in Flutter now. So that's great. You said it's a pretty popular framework, which actually seems to be true looking at the stats. Like there's, for example, the JetBrains State of the Developer Ecosystem survey, which said, it's been the most used multi-platform app framework since 2021. And there was some more stats from Apptopia, for example, that says that Flutter accounts for nearly 30% of all new iOS apps. So that's quite a lot. So Flutter is a big thing in native. Flutter is becoming more and more popular on web as well for some kind of apps that people are building. Especially when they target multi-platform, where it's not just native, but also web, or not just web, but also native. But the third I/O moment that I want to mention is obviously WebAssembly. That's why you're here. So last year, when they announced that now in Dart you can compile to WebAssembly and compile your Flutter apps to WebAssembly, there was a big change in the ecosystem coming from Flutter compiling to JavaScript and now Flutter all of a sudden compiling to WasmGC. But maybe before we dive into WasmGC, let's very briefly touch upon the history again. So in the beginning, Flutter and Dart compiled to JavaScript. So if you were building a Flutter application for the web, it ended up being in JavaScript, running in JavaScript. But then, why did people switch to WebAssembly and then more specifically WasmGC?
Yeah, so from the very early days when Dart was targeted to be in Chrome, we had this Dart2JS compiler that was used as a fallback for browsers that wouldn't have the Dart VM inside. But then Dart VM didn't end up in Chrome, and so it became our main production target, how we compile to the web, because there was only JavaScript available at the time. There were some kind of intermediary stages on the web. There was like Knuckle, Pinnacle, SNJS, some things like that. But
we talked about those in the episode with Alan Sakai, if you want to learn about those. So quick sideway here.
And then, so we had the Start2JS compiler, but we were never super happy about this, the fact that it has weird semantics. You compile to a high-level language instead of a low-level language. And there's performance cliffs you can easily run into. And so we always did some experiments. We had some internships that took our native compiler that was used to target mobile, and we added the backend, so kind of experiment to backend to LLVM, which we then at the end of the internship tried to compile to linear memory Wasm, and the performance was nice, but we were never kind of convinced of the idea of shipping our own garbage collector. because Dart is a managed language like Java and JavaScript. But if you compile to linear memory, Wasm, you would need to ship your own garbage collector as part of the Wasm module, and it's not very memory efficient. Like you allocate a big linear memory, you commit to that. Maybe you don't use only part of it, but maybe use it at some point. You cannot easily free subparts of it. And there's already a garbage collector in the browsers, which is used for JavaScript. So when we heard about the initial kind of draft of WasmGC specification, we were very excited. And so there was another internship we hosted that then tried to target, this time not via LLVM, but directly as a backend to our Dart AUT compiler to target WasmGC. And we were very happy with the outcome of this experiment we did in this internship. And then we decided to rewrite a new Dart to Wasm compiler in Dart. And yes, and we were hoping for the goals were always to have a better startup latency. This has been a long problem in JavaScript. Some of our big customers, they have very, very large apps that can maybe take seconds to start up. And Wasm has a promise of doing that much better. And also peak performance. You don't have these performance cliffs where at runtime the JIT compiler optimized something, speculated on something, and then this speculative assumption doesn't hold and everything gets deopted and suddenly the code runs slow. So to have a more predictable performance and better peak performance as well.
Very interesting. So you said you heard about the WasmGC proposal. Were you somehow part in championing it, or is this just something that you took as a customer?
It was, I think, already proposed. It wasn't finalized. These Wasm specs, they go through various phases. It was in the earliest phases. And a former member on the Dart to Wasm team, Eske, he engaged also with the specification committees, provided feedback based on our compiler. And so we had a little bit influence, I think, on the WasmGC spec. But it was not driven by us.
Understood. So when you think about Google, people tend to think of it like as that one big corporation that is sort of connected somehow. And if someone says something, they say it on behalf of Google. But I think internally, the way it works is that the Flutter team at Google and the Dart team at Google, of course, collaborate, but they're separate teams. So you were moving the language forward, like the Dart to Wasm compiler project, for example, was an independent project, while the Flutter team were just happily using the old school way of using Dart to JS as a compilation engine. And they were just essentially waiting for you to do the work. Is that a correct representation of how it worked internally?
Yeah, I think, yeah. So we experimented with Wasm before. Flutter even knew or asked about it, and we made this compiler. And from there on, it was a collaboration. Then when the compiler was a bit more mature, you could run more and more Dart code on it, so implement more semantics, library features, and so on. Then the Flutter team was very interested in using it. And it was a great collaboration because whenever you work on a project, you really want to have feedback on what you're doing to steer you in a direction where you put your resources where you can have value. You see the shortcomings of things. And so it was great to have them as a partner. But of course, you can use Dart to Wasm also to make DOM-based web apps that are not related to Flutter. There's, for example, a more increasingly popular framework known as Jaspr. They use Dart to write DOM apps, and it also has a way to opt into using Wasm for that.
Yeah, interesting. We will go into this in a little bit. Before I wanted just to provide some more, or wanted you to provide some more background on WasmGC. So from an external point of view, it sounds like, yeah, we had linear Wasm, which was just there, the Wasm 1.0. And then people started to compile managed languages like I don't know, PHP, JavaScript, and so on. I tried to compile those and realized, we need to compile the entire garbage collection code when already in the browser we have a garbage collector. So it sounds like a simple thing to just say, if WebAssembly needs to do garbage collection, just call into the thing that the browser already provides. But it's not as simple as that. So if you look at the WasmGC proposal, it's mostly about structs and data structures, essentially. So it doesn't really even mention garbage collection. It's just something that is assumed by compiler experts to be the things that you need for doing garbage collection. But can I maybe for a little bit more laypersons define or explain how does it work? How do you compile a managed language to WasmGC?
Ömer, maybe you want to take this one?
Yeah, sure. So the Wasm spec leaves the garbage collection implementation details to the basically the engine to the engines, and it defines the heap objects as structs and arrays, and they are typed as well. So when you use them, you only use them in a safe way. You don't get like segfaults or similar like you would in a native language. The garbage collection is done. In practice, all the engines implement the garbage collection, so you don't have to ship a garbage collection. If you have multiple Wasm apps shipped in a single web page, you don't ship multiple garbage collectors in each of those Wasm code in that page. So it's just it's something that all the engines do.
Yeah. So the GC specification, it's like it's all basically, as Ömer mentioned, structs and arrays. These are the additional objects you can create. There's instructions for that, and the browser or usually the JavaScript VM implementation will have a garbage collector that collects those objects. And when you have a high-level language, we compile it to a low-level language, but it's not machine code. It's structured. It has a type system. So structs can form a kind of hierarchy. You can have a struct that is a substruct of another struct. It's strongly typed. It has been designed in a specific way that it is easy to verify that the bytecode is correct in a linear path compared to, for example, Java, which they learned from that mistake.
It's also designed in a way that that allows you to refer to the host objects and allows host objects to refer to your Wasm objects. So you can form cycles there. And in practice, usually is the same garbage collector. So in the browser, you have just the JavaScript garbage collector that handles all of those objects. It's quite flexible in that sense, and saves you quite a lot of binary space and the implementation effort as well.
So WebAssembly started, of course, in the browser, but from the early days on, there was this thinking that this could be useful outside of browser context as well. So if you think of Wasm non-browser runtimes, they typically can't just say, we already have the JavaScript engines garbage collector, so they need to hook into something that they provide, or like how does it work for non-browser Wasm runtimes?
They have to implement a garbage collector, or they will be leaking all the heap allocated objects. You have to implement. So as far as I know, some of the native engines like Wasm Time, for example, they've been working on a garbage collector implementation. But you don't have to do it. But then you would be leaking all your structs and arrays. They would never be collected. But you have to implement it. Yeah.
So when you first started switching from Dart.js to Dart Wasm GC, can you just talk about the performance differences that you noticed? Obviously, the runtime code is more or less the same, so it does the same things, but hopefully there was some measurable performance impact. Can you talk about that?
Yeah, maybe I can start. So one of the advantages of WebAssembly compared to JavaScript is that you have these typed arrays and unboxed numbers, integers, floats, and that kind of thing that you can easily get in JavaScript. So if you have that kind of code where you have like type loops operating on arrays, numbers, that kind of thing, you have SIMD instructions now in WebAssembly that allows all kinds of new things. So if you do that kind of thing, then that's an easy win on the browser when using WebAssembly. But if you, on the other hand, because WebAssembly can't do like DOM operations by itself, it doesn't have DOM instructions. That's up to the host implementation. So you have to call host functions for that kind of thing. So that's the other thing that you do commonly in the browser. And that's, I think, one of the challenges with WebAssembly running in the browser, where if you do lots of DOM operations or bullet pixels on a canvas or something like that, using only WebAssembly code for one DOM operation at a time, like for every DOM operation, you call a JavaScript function or things like that. That's the other thing that you commonly do, which is not probably much more difficult to get faster by compiling to WebAssembly. But for computation, numeric computations, that kind of thing, if you do heap allocations, arrays, structs, and mostly operate within the Wasm instruction set using Wasm objects, then that's an easy win in the browser.
Yeah, so Flutter as the framework using Dart, they in their I/O moment mention that some of the, so because it's everything rendered on a canvas, the frames per second is an important metric, and they mentioned that they get up to twice as fast rendering with Dart compared to JavaScript. So I think that's quite some massive achievement there that your team made. But let's go back from canvas to DOM, because you mentioned with Dart you can build web applications that actually use a traditional DOM. So how does it work? Did you just map every single like document create element, document whatever query selector to the corresponding Dart functions, or how can people imagine building web applications with Dart without using Flutter?
Yeah. So at the end of the day, you have to really map all those operations that you need in the browser. That could be DOM, Canvas, whatever else, other APIs, other HTML APIs. You have to bind all those. You have to import those in your WebAssembly code. So in that level, you just declare those as if they are like foreign function interface functions, like you would do in a native app. And in the at the WebAssembly level, those would be imports. But yeah, someone needs to do the mapping, create all those bindings to DOM operations and other browser APIs.
Yeah, and we have a package for that. So it's more like a declarative Dart-like syntax where you define the JavaScript API. It's using our new extension types in Dart, and for DOM specifically, for those APIs, we have pre-made a package with those bindings in that you can just use to access the DOM. And on the low level, it will, as Ömer said, will just compile down to Wasm imports. And what it imports is some JavaScript functions that we generate that will then call the DOM APIs. And of course, that is not as fast as having it in JavaScript directly, because you have this transition from Wasm to JS. But we were actually surprised that in many cases that the overhead is not like exorbitant high compared to just JavaScript, because the DOM APIs, they are also not implemented in JavaScript. They are implemented in C++, in Blink, for example. And there's also overhead there of manipulating the DOM, creating C++, DOM nodes, and so on. And so it's not a massive slowdown, but it is. You can notice that it's not as fast.
So you mentioned types before, and that's a good segue to my next question, which is essentially JavaScript is a non-typed language, but of course, programmers, developers sort of like types. So the JavaScript ecosystem invented first Dart, and then of course TypeScript, CoffeeScript, and so on were just some ways to try to make this a little better. But then we have also this approach from, for example, the Kotlin folks that mapped the DOM JavaScript functions to Kotlin functions. You do the same in Dart. But if you look at it from a developer angle, like you try to read the docs, and if you read the MDN docs on the JavaScript DOM APIs, and you read the Kotlin docs or the Dart docs for all of those, it seems relatively comparable from an learning curve kind of perspective. So if you start fresh, I think it doesn't make a big difference if you start, like, assuming everything performance were non-relevant. If you would just look at it from I have a background in Dart, as a background in Kotlin, I want to do web. There might be not a huge overhead in learning coming from Kotlin or coming from Dart in learning the JavaScript APIs. But what do you see for people to be the main motivation? Is it just the types that people have? Is it the ecosystem that they have? Is it the developers that they already have that are familiar with Kotlin, Dart, whatever? Like, why do people do this instead of just going JavaScript directly?
I think JavaScript was designed over a few weekends in the 90s, and it was not originally designed to be a scalable language. So if you have very large applications, you wouldn't want to handwrite in JavaScript. If you want to refactor your code, it becomes difficult. You also don't have type system guarantees, nullabilities. The famous thing that you can compare a number to a string in JavaScript and it may return true. Weird things happening, and so it helps to have some structure for larger applications. And it also is good for developer tooling because it means in your IDE you get code completion and for everything.
And regarding like the question of why compile Wasm when you can compile JavaScript, I think that was is that the question, like you could compile to JavaScript with Kotlin, Dart, and many other languages, or you can compile to Wasm. Why do you want to compile to Wasm? I think I have an answer to that. That's kind of a long-term benefit of Wasm, not in the short term. We're not seeing it in the short term, but Wasm liberates your language design from JavaScript constraints. So that's one of the things. If you look at Dart, for example, you have this regex API that's identical to the JavaScript's regex API, and you have this type data API that's identical to JavaScript's typed arrays. And the reason is because there's no other efficient compilation of something like a typed arrays to JavaScript that will be efficient, and also in terms of code size as well, because you don't want to ship a whole regex engine with every Wasm module that you ship, also a JavaScript file, every JavaScript project. So with the JavaScript, the only way where you could have efficient binaries in terms of binary size and runtime was to have a semantics that's very similar to JavaScript. In fact, in Dart is identical. The Dart regex is identical to JavaScript regex, and Dart typed lists are identical to JavaScript typed arrays. And now with Wasm, now we have this more flexibility. We have efficient arrays, which in the future will have multi-byte access API as well. Today you can't do that, but in the future we'll be able to do that. And with that kind of thing, it will allow your language semantics to move in different directions. You don't have to just do as JavaScript does for runtime efficiency or binary sizes with WebAssembly.
And like I touched on earlier, like when you compile to WasmGC instead of JavaScript, you benefit enormously from, for example, startup time. We see like 5 to 10x faster startup time depending on app size and so on. Has also to do with the fact that it's a binary format, it's structured, has been designed to be verifiable, the bytecodes in one pass. In JavaScript, it's different. You have to pass from UTF-8 encoded bytes, read from top to bottom. You cannot just skip over a section. You don't know where the matching parentheses and braces are. And so that's one area where we benefit a lot from startup time, but also like we see, depending on what you look at, like integer factors of faster performance. One interesting thing is, for example, that the JavaScript type data APIs, as Ömer mentioned, they have weird performance cliffs. For example, you can have a 4x4 matrix, so 16 elements, I think. There, if you have a type data that there's 16 elements, it's kind of fast to allocate. If you have one that maybe 17 or 20, it's going to be massively slower because suddenly it starts to allocate this into C memory using malloc instead of in the JavaScript heap. And there's reasons for that because the JavaScript APIs, they are flexible. You can transfer buffers and things like that. But in Wasm, you just have a typed array and you have predictable performance. You allocate it. We see good things in peak performance. There is some cases where JavaScript is some workloads are outperforming when you compile them to JavaScript compared to WasmGC. But I think this is only a matter of time until the engines improve. One example is that if you at compile time you have a call, but you don't know where you're going. It's like a virtual method. It can be overridden by a class. We use call indirect, which calls via a table. And in JavaScript, which the engines have been optimized for over a decade, they are like learning machines. They see at runtime, okay, you used to call this once, twice, many times. I'm going to assume you always call this and just inline the body. And if the assumption failed, you de-optimize this code. And the WasmGC runtime, the compilers, they have not done all these optimizations yet that have been done on the JavaScript side. But we have seen this coming now. For example, V8 has started to implement speculative inlining in WasmGC code. So I think these kind of narrow cases where WasmGC code will be slower than JavaScript, it will very soon disappear. And so we on the Dart team view that WasmGC is like pretty much superior to compilation target compared with JavaScript.
You mentioned the size argument before. So JavaScript obviously is textual, whereas Wasm is binary. If you take the same application and compile it to Dart.js, or to compile it with Dart.js versus Dart Wasm, size-wise, do we have a like generalizable, more or less, metric that it will be half the size, it will be whatever, a third of the size? Can you just give us some rough idea here?
The size is comparable. The compressed size sometimes compressed size of Wasm is a little larger because the text-based format compresses a little better. But the startup time, what matters in the end is a user goes to a web page. How long does it take to display the first frame? And there's several components to that. There's the network bandwidth. How long does it take to download it? And that is one aspect, but you also have to consider what happens in the runtime when it has downloaded this file. And in Wasm, for example, it can download and verify in a streaming fashion, which I think in JavaScript is not done. And compiling the Wasm code is much, much faster. So they have baseline compilers. I think they can compile more megabytes of WasmGC code per second than you have download bandwidth.
Which from a practical standpoint, essentially all boils down to use the tools for what they're good for. So you would not use Flutter or you would not use Dart with the DOM APIs to build a content site. You would build it to, you would use it to build actual applications in a sense of an image editor or like an actual thing that is an app and not a content site. So you wouldn't build whatever, a news site with those technologies. So
probably not. But we are actually seeing that the base cost of like a Hello World app compared to Wasm is quite small, relatively small. So depending how much logic you have, even for smaller things, it may make sense. I think on the Dart, the dev website, we use now the Jaspr framework it's normally like content-based website with documentation, but there's some page where you can download and select the right version of Dart you want to download. I think this is also may already run in WasmGC mode now. It's a very small app that is part of a like content site.
Interesting. So you mentioned Jaspr now several times. Let's maybe talk a bit about it. Is this something that the community built? Is it something that someone at Google built? What is Jaspr? Who is behind it?
Yeah, so we have nothing to do with it. Google has not done that. It is a Dart framework for writing web apps. It has support for server-side rendering and the client-side rendering. It was somewhat inspired by Flutter. So the APIs, a Flutter developer would feel kind of like at home because widgets are created in a similar way, but it's not drawing on pixels. It's making DOM nodes under the hood. And it has the option to compile to WasmGC, and it was created by Schultek. I forgot his first name. From Munich, I think. And I think it has increasing popularity. He may have even made some VS Code extensions for it and so on. But Google was not involved in that. So it's great to see the community picking that up. You see also that the usages outside of Flutter, like there's now server-side frameworks using Dart. For example, one is called Serverpod. So yeah, it fits the spirit of being a general purpose language that you can run it anywhere.
Yeah, that's great to hear. So if you look for Jaspr, of course, we're going to link it in the show notes, but it's Jaspr without the trailing E. So it's not Jaspr. So now instead it's Jaspr, like Flickr, if you remember that. So be sure to search it without the last E. Okay, so talking about the server, this is a great lead into my next question, which is about current challenges. And you mentioned that right now, Dart can compile to WebAssembly GC just fine, but there's some limitations when it comes to, for example, non-browser runtimes. And you have an issue open there in the Dart-Lang SDK GitHub repo. If you want to check that out, it's 53884. Can I just go into a little bit more detail? Like, what are the limitations there? Why does it work so well when you are in the browser, but not so well when you or like has some challenges when you run outside of the browser if you use it with or try to use it with something like WasmTime or Wasm, like the classic command line runtimes of WebAssembly?
Yeah. So I think so one of the advantages of WebAssembly that we mentioned that it kind of liberates your language from JS semantics. So now in Dart, we have this language that we've been compiling to JavaScript for many, many years. And now it has this APIs that I mentioned that kind of mimic the browser APIs with the typed arrays and regex and that kind of thing. Those would need to be compiled differently when running natively. Because now you don't have a browser, you don't have the HTML API, you don't have the typed arrays there. So those, one of the challenges is that you have to do those in a different way for the native. So that would mean a separate library for Dart typed arrays, for example, typelets or regexes and that kind of thing. This is just to name one. And there are other things like the WasmGC is not widely supported in the native engines as far as I know. So you would need a solution there or just accept linking your heap objects.
What about WasmGC in browsers now? So it's in Chrome. I wrote the article about it, but we announced it. I think it's in Safari and Firefox as well. Is that correct?
Yeah, I think it's supported by all the major browsers by this point. And now there are some follow-up work to the GC spec with extending some of the data structures like arrays with multi-byte access, for example. And those are being designed and implemented.
There's kind of this interesting aspect that there was like a longer period where WasmGC was being developed and specified, and then it had a 1.0. And this is what we use as a compilation target right now. But there's some new specifications, new discussions in the community going on. One of them was JS string build-ins that Ryan Hunt from the...
We also had an episode on that. So if you want to listen back to the Ryan Hunt episode, definitely do so, yeah.
Yeah, and we take advantage of that, but here's the catch that for JS string built-in specifically, they are implemented, I think, only on Chrome and Firefox and not on Safari yet. I felt a bug about that, but I think it has not been done yet. So you need a polyfill. And for specifically the JS string built-ins, we can polyfill them. But for other Wasm specs, it's a little bit harder to polyfill, especially if there's new instructions, because every Wasm runtime is required to validate the Wasm it gets. And if there's instructions in it doesn't know, it will complain about that. And so there's this, it's going to be a bit more slower moving, or you have to compile your app in several different ways, with and without certain features, and at runtime select which version to use depending on which browser you are on. Yes, and Flutter does that also, not only because Wasm, it doesn't only require Wasm features, it also has some extra requirements because it gains some of the performance benefits by moving rendering to a worker thread so you can do off-screen canvas rendering. And there's some performance problems in some other browsers. I believe in Firefox and Safari, there's some issues with having like 0 copy of those off-screen rendered textures back to the main canvas. So there, it shows that there is a little bit kind of fragmentation, and it's also with the performance similar, that just because you can compile to WasmGC doesn't mean it's gonna be running faster. It depends on what optimizations which engine is doing, and depending on that, you may want to runtime select. Do you use Wasm or not? Do you use it on those browsers where you know it's gonna be faster than the two JavaScript compilation?
So let me summarize a bit. So you mentioned on the non-browser runtimes like Wasm, WasmTime, and so WasmTime, Waspr, and so on, there's just no WasmGC support quite yet. So you need to find a solution for that. On other browsers that do have WasmGC support now, it may be just a little bit slower. You mentioned, yeah, you may need to selectively choose what version of your app to deliver. So we have a library for that where you can detect what browser features your particular browser supports. So then you can select dynamically more or less what Wasm package to ship. But very bluntly, so if I were, let's say, the CTO of a company and we were thinking of building this massive new AI-powered image editor or whatever with Dart, with Flutter, and we were hoping to target WasmGC, would you say it's too soon? Would you say it's the right moment? Would you say do it, but just be aware that it might run slower on certain browsers and faster on others? Like, if you were to just be the person responsible for taking that decision, what would you recommend them?
I would say do it with Dart, and then in runtime select between JavaScript or Wasm depending on the browser. That's one of the advantages of if you can compile to both in a single language. That would be my answer.
And in fact, Flutter does make that choice. So you have to, when you build your Flutter web app, you opt into Wasm. You say I want the Wasm enabled build, but it will automatically compile both versions and at runtime select. So it has the logic to say which browser at which version do we want to select the Wasm version, because we know it's gonna be superior over the JavaScript version. And some browsers, they may not have done all the optimizations. They may not have the right performance in these kind of graphics APIs, and there they may choose to select the JavaScript version that is like single thread, for example.
So that's amazing, because you, as a developer, you don't have to care. You just essentially wait for the engines to catch up, and then the Flutter engine will do the right thing for you.
Yeah, I just wanted to mention that then in the long term, then over time, you would see that you are choosing the Wasm build more over the other one as the engines catch up with the new features and the optimizations. And then hopefully in like 5 to 10 years, there would be no JavaScript. That would be my hope.
And then I guess at some point Flutter will make WasmGC not the opt-in, but not the opt-in, but the opt-out.
Yeah, we are working on that at the moment.
The ecosystem would just slowly evolve. That's amazing. Do you want to go a little bit more into the concrete things that are challenging right now? Or is this something that you expect people to read up on, like the certain bugs that you have filed? Do you think those bugs will be acted upon? What is your hope there?
Yeah, so in terms of challenges, I think the users, I would want users to know at least that you don't expect. I mean, we are excited about Wasm. We know it's going to be great in the 5 to 10 years, perhaps. But when you compile your JavaScript app, your Dart app that's today compiled to JavaScript to Wasm, it doesn't automatically get faster in all the aspects. So you have to be aware that, for example, we mentioned about these JavaScript APIs that Dart had to mimic, like the typed arrays and regex and that kind of thing. Those are basically foreign function interface kind of calls to JavaScript today, and those are not optimized the same way as JavaScript to JavaScript calls. So if you have a regex call in your JavaScript app, that's at the engine level, that's represented differently, that's optimized differently than a Wasm module calling a browser API. So that kind of thing is currently I think a big challenge at the engine level, where ideally we would want to see, like, because that's the same engine, if I'm calling JavaScript from WebAssembly or JavaScript from JavaScript, I would hope that they're optimized the same way. But that's not the case today in any of the engines that I'm aware of. So with that, if your application is heavy in that kind of thing, you do lots of DOM manipulation or bullet pixels on canvas doing JavaScript calls, that's going to be probably slower today.
I would hook in there a little bit. That was our perception, but it depends how much logic you do in Dart, or if you use another language in that language versus calling to JavaScript. And for example, this Jaspr framework, it's manipulating DOM, so it is very heavily operating on the DOM via these kind of indirect calls to JavaScript, which then operates on DOM. But what we see is we wrote a to-do MVC app, which is the classical kind of benchmark browsers I've used for a long time. And we wrote it in Jaspr. And it turns out it's a little bit faster than the Dart2JS version when you compare it to Dart2Wasm, even though the calls to the DOM APIs itself might be a little bit more expensive. It's not like 10x more expensive, maybe 20-30% more expensive. The fact that you do application logic as well, and that application logic is much faster than in JavaScript. So it compensates for this extra overhead. So it depends a little bit what you do. If you just have a loop over inserting DOM nodes, it's going to be faster than JavaScript. But if you have some real application logic, it might be very well worth trying to compare to Wasm.
Or maybe you could use some tricks like doing your business logic in Wasm and then maybe batching your DOM calls in some JavaScript call so you do one JavaScript call which does lots of DOM calls and that kind of thing. So you may be able to refactor your code for optimizing this as well.
Yeah, so talking of tricks, one of the tricks that I hear people at Google mention sometimes, if something is slow in one browser engine, they try to get it into a commonly shared browser benchmark, like Browser Bench, for example, is a common one, or a speedometer, these kind of things. Are there any WasmGC related tests or benchmarks in Browser Bench or a speedometer, any of those?
Yes, so we have added one benchmark, which is a kind of subset, or it exercises the same logic as Flutter apps exercise, but it doesn't draw on canvas if this part is stopped out. It's called Flute, and we have landed this benchmark. I think it's maybe an experimental workload at the moment in Jetstream, I believe. And we are also in the process of trying to get the other version, one that exercises this WasmGC JavaScript boundary a lot, using this to-do MVC example written in Jaspr. We try to get this benchmark into the speedometer benchmark suite.
Amazing. So you're playing the tricks. Nice. So we will see. Hopefully it will pay out. Hopefully the performance cliffs that you might be hitting on some browsers today might be going away, and all of the browsers move forward faster with WasmGC in the future. Yeah, we talked about the past a bit, so diving back all the way to how even Dart came to be and Flutter came to use Dart, and then we talked about the present, like where we are now, what we're doing. Let's talk about the future real quick. So what is one thing that you'd wish for in the Wasm ecosystem?
I think I already mentioned a little bit. I'd like to see this distinction of different languages in the same engine to disappear. If I'm calling JavaScript from WebAssembly, I'd like to see that to be the same as calling JavaScript to JavaScript. It's kind of like if I compile Clojure and Java to JVM bytecode, it's the same calls. Even if I use different instructions, kind of like the same representation in at the engine level. I'd like to see that happen in the browser, but I don't know if that's realistic or practical.
Yeah, makes sense. Martin, anything from your end?
Yeah, there are these smaller performance things like optimizing this boundary to JS, especially for common APIs like accessing type data, regex, things like that. One could even think that maybe it would be possible eventually in the future to have direct kind of a Wasm interface to the browser APIs. Why do we have to call via JavaScript those APIs? If there was like already these browser APIs, I think they are written in an IDL and in some interface description language, and so it's kind of a typed semi-typed description of the browser APIs. What if we had that for Wasm and you could directly call it like that, bypassing JavaScript? And that would be an interesting thing.
Yeah, we had Mandy and Sean from Render.let on the show recently, and they mentioned about such a project where they mapped essentially all the IDL APIs so that you could use them more easily. But yeah, so anything else that you wanted to?
Yeah, there's a bunch of kind of promising spec proposals. One I'm very interested in is the shared memory multithreading proposal. And that comes like from any kind of UI application. You have relatively strict requirements about UI responsiveness. You would like to have animations run in 60 frames per second, and but you may do other things. You may call network, you may decode a large JSON, you may do some computation that doesn't fit in these 16 milliseconds of budget. And you would like to offload that to another thread. Why not? So this is what you would do on like mobile apps, for example. You just spawn a thread and you move the logic there, and when the network request is done, you have passed all the JSON and you have what you need for the UI. You ping the UI thread and it's gonna update. And right now this is very hard on the web. You can spawn a web worker, some heavyweight thing, and it communicates with message passing. You have to copy messages forward and backwards, and it's not so convenient. So there's this proposal about shared memory multithreading where in the Wasm type system, there's a distinction between functions, shared functions, I believe, and which kind of structs, fields can be shared, not shared. There are some challenges there, especially for like any kind of nominal typed object-oriented language, because in Java, Dart, and so on, there's a top type, there's object. You can assign anything to objects, and this means that in the current proposal that that you may want to compile it everything in shared types, because shared cannot point to non-shared, and that creates some interesting challenges. And if you compile everything in shared types, how can you access a DOM node or anything like that that is not shared? You cannot access a DOM node from other threads. You would only be able to access it from. And there's some interesting discussions happening there with kind of thread-bounded access references and things like that. Yeah, so this one I'm quite excited about. It also shows some interesting thing why it's not as easy to optimize calls into JavaScript, because the Wasm code that the Wasm compiler generates, it is runnable on any thread. So it cannot inline some JavaScript stuff that will only run or work on the UI thread that easily. So that's I think one of the reasons I heard that it's a little hard to do this, and there's others like the optimization support and things like that. Yeah, and there's some other kind of interesting proposals like stack switching, for example. Ömer worked on our async implementation.
Yeah, so we with that stack switching, you have to compile your async functions into state missions yourself today, and that adds some binary size overhead, and the runtime performance is also not ideal. So we are hoping that with the stack proposals like stack switching, that could be used for Dart's async functions, and we would generate smaller code, and it would run faster.
And it has kind of this non-local effect, because right now Each async function is like a state machine. You continue running it. You hit an await, then you have to suspend it. You continue running it in the state machine, but you suspend and resume one particular function frame. Whereas if you had a real stack switching, you could just call all the way down and then suspend the entire stack and resume it. So you have this not on a function level, but on an entire stack level. So that has also some nice performance improvements. And
Yeah, I can see already this is not gonna get boring anytime soon with the visions that you have ahead for Dart, for Flutter. We're unfortunately running a bit out of time, so maybe we should get you on the show again in maybe 3 years or 5 years or so, when some of those visions that you have today may just be the future of, the present of the future. So we will see. But with this, I want to open the door for the last part of the show, which is always Wasm, but not. So when you instantiate streaming on any of your streaming devices, what is it that you currently watch or listen to? And I think you wanted to split the question. So I think this one is taken by Ömer, if I'm not
You
mistaken.
can take this. So these days, not much, to be honest. In the past, I would do a lot of podcast streaming as I exercise, non-technical topics like history and philosophy and that kind of thing. These days, with side projects and parental obligations, I don't have much time, but I still do the same as much as I can, just podcast outside of technical topics.
But it's a healthy thing to do. So don't listen to WasmAssembly while you're parenting, I guess. Awesome. And then the next question is for Martin then. So if there's one thing that you could local get, as in something that you do, and then global set upon the world, as in something that you wish everyone else did, what would it be? And if you want, you can also swap the question around.
yeah, it's a challenging one. I really like to work in NeoVim as my editor, but the whole world seems to be centered around VS Code and VS Code forks. And so I would like to give some love out there for people to try kind of modal editors like Vim, but also more abstractly, like try out new things, old things, different things, not only technical, how to try cooking some Chinese dumplings, some different cuisine. And I think I do that also too little maybe in my life to try out new things, try out a new keyboard or yeah.
Leaving your comfort zone, essentially. So yes, that's something that most of us are not good at. I'm certainly not good at it. I write my commit messages in Vim, but mostly just because it's the default and that's the way I learned it. I'm always glad if it works out. Every now and then I just quit and just start from scratch because I don't know the keyboard shortcuts, but I never really learned them. So I'm a little ashamed to commit that, but I'm a VS Code person. I have to admit it. But yeah, I always admire when people have those super elaborate setups with several terminals open and everything. So I'm not one of those persons. I have a bunch of terminals in tabs open, but like nothing multi-window. But yeah, maybe I should be leaving my comfort zone and try it out, time permitting. And I think that's the overall challenge that we all have, right? But like time permitting, we're almost like 4 minutes over the hour already. So let's maybe come to an end. And at the end, I always ask our guests if people listening to you, if people watching what you have to say have questions. How can they reach out? Do you use social networks? Can people email you? Like, yeah, who wants to start? Maybe Ömer first.
Sure. I didn't use social media that much, but I'm on LinkedIn, so you can message me on LinkedIn or just email me. My email is available on my GitHub account.
Perfect. We will link to those. And then from admin.
Yeah, same for me. Yeah, LinkedIn or email. I do have a Twitter account, but I'm not super active on it. So.
Perfect. Whatever works. So if you have questions to Martin or Ömer about Dart, about Flutter, definitely reach out to them. And with that, yeah, thank you very much, the two of you, for being on the show. I learned a lot. I had some assumptions of how things worked and were in the past, but even working at Google, being around when things like Dart were announced, some of it I've forgotten, some of it I just didn't know because I wasn't watching closely enough. But yeah, I learned a lot about the history, about the present of this language and the main customer that is using it, but also internally, externally about the ecosystem. Like Jaspr, I had no idea that this exists. I had no idea that people build web applications with Dart and properly render 2 DOM nodes and so on. So, wow, that's so great to host this podcast and have people invited and just explain things to you. So thanks again for being on the show. And with that, looking forward to my next guest. I don't know who they will be, but I'm looking forward to learning more about the next guest very soon already. So thank you very much, and I see and hear you next time. Bye bye.